In this section, we will learn about RLC phasor diagram and phase shift. In the previous sections, we analyzed the RC and RL circuit with AC power supply. Okay, in general, we can have a circuit with all three components, okay, R, L, and C. When we have all the three components, the way we analyze is the same. Okay, we just add the three impedances. Okay, the impedance of resistor is this. This is the impedance of the inductor, and this is the impedance of the capacitor. When we add all three, we will get this equation. Okay, we can note here, if the impedance of the capacitor is larger, which means this component will become bigger than this component, then this whole part will become negative. Okay, so if the whole part becomes negative, it means the circuit is more capacitive. Okay, if the imaginary part is negative, more capacitive. If the impedance of the inductor is bigger, then this one will be bigger, which means the whole thing will become positive. So if the imaginary part is positive, then we know it's more inductive. The inductor is more dominant. Okay. Now, once we have the impedance here, we can easily find the current. If you're not sure, go and refer to the previous section. Just take the source voltage, divide by the impedance, and then we write it in the polar form. Okay. And we have already seen, once we write in the polar form, if the angle is positive, that means current is leading. And this, if current leads, that means the circuit is capacitive. Okay. So based on the current also, we can identify whether the circuit is capacitive or inductive. If current is leading, then the circuit is capacitive. If current is lagging, okay, this is the case, current is lagging, where the angle is negative. Okay, the angle here is negative. If current lags, then we know it's inductive. Okay, so if current leads, the voltage capacitive, lags means inductive. Here I've also shown how the waveform looks. If the current is lagging, the current is leading for capacitive, it means the current will start first. Okay, you can see at 0, the current is larger. The peak of the current comes first, then this peak of this is your current, this is your voltage. This is the case where its current is leading and it's capacitive. Okay, if the voltage is leading or the current is lagging, okay, here the current comes later, voltage comes first. This is the case for inductive circuit. Okay. Okay, in this part I'm going to explain, if you are given the waveform, the current and the voltage waveform, how to find the phase angle. We see, okay, let's say this is your current, this is your voltage. Then the difference, the time difference between these two waveform is, you can take any two identical points. For example, these 2 points, we take the difference here. This is the time difference. Okay, you take this time minus this time. You can also take this time minus this time, or this and this. They all will be the same. Okay, so here we get the time difference. This is the equation for phase shift. We take the time difference, we divide by the period. The period is, how to find the period? Period is one cycle from here to here. Okay, the time from here to here. So if we take this, we know the period. Or if the frequency of the waveform is given in the question, you can just divide 1 over frequency to obtain the period. Okay, so this is the period. Now if we divide these two and we multiply by 360, we will get the phase shift. This is the phase shift. Okay, this is equivalent to the angle over here. Okay, I have given a small note here. Again, to recap, if the circuit is capacitive, then your current will lead, which means if you look at these two circuits, if this is capacitive, then this one will be your current and this one will be your voltage E. On the other hand, if the circuit is inductive, then the voltage will lead or the current will lag. So this will be your E and this will be your I if it is inductive. Okay. Yeah, that's all. Thank you.